McCormick Place in Chicago, Illinois, the largest convention and exposition center in North America. And going on inside is the NPE, one of the largest convention and trade shows in the world, all dedicated to just one industry, plastics manufacturing.
I heard today in a talk here at the NPE, a man who's been in the business for 35 years. He said in the last year there have been more new polymers introduced than he has seen in the previous 30 years. There's growth, there's opportunity, there's science in action, there's the place where you want to be if you want to do new things.
Over 1,700 companies from all over the world come to show their equipment and technology and to exchange information and ideas. And 83,000 attendees from the automotive, chemical, medical, electronics, and many other industries come to see what these companies have to offer. What the plastics manufacturing industry has to offer students who are getting ready to enter the working world is unlimited opportunity. The opportunity to work in an exciting, expanding, and interesting industry where the choice of jobs and companies is wide open. But those companies are looking for educated and trained people, persons who can work on a daily basis with a variety of advanced plastics technology in use today. Although plastics technology has become infinitely more complicated and the different types of plastics number in the tens of thousands, the basic steps in processing most plastics are fairly simple. Melt the plastic by heating. Form it into the desired shape. Harden by cooling. Plasticize is a more precise term for making the plastic into its liquid form, but melting is more commonly used. How a plastic is manufactured can depend on whether it's a thermoset or thermoplastic type plastic. Although there are numerous different kinds of plastic resins, all plastics are one of two kinds, thermoset plastic or thermoplastic plastic. What's the difference between a thermoset plastic and a thermoplastic plastic? Let's try an experiment. If we put both a thermoset and a thermoplastic on a hot plate, they both melt. But if we let the plastics cool and harden, then try to melt them again, only the thermoplastic will remelt. Thermosets, once melted and hardened, will not return to their plastic state if heated. Thermoplastics can be melted, processed, and hardened again and again. Just as there are a multitude of different kinds of plastic resins, the number of different types of processes used to manufacture plastics into products seems almost infinite. But all plastics processing can be put into a few broad categories: molding, extruding, reinforcing, laminating, casting, thermoforming, expanding, coating, decorating, machining, finishing, and assembling or fabricating. In this video, we'll take a look at some of the most common plastic manufacturing processes and the steps and technology involved. We'll see compression molding, injection molding, extrusion, extrusion blow molding, blown film extrusion molding, thermoforming, fastening or ultrasonic welding, and decorating. A basic assumption in all plastics processing is that the raw material will be made fluid or plastic at some point in the operation, but later hardened. To be classified as a molding process, force must be applied to the plastic when it's in its fluid state. Plastic molding processes are numerous. They include compression molding, injection molding, reaction injection molding, transfer molding, vacuum injection molding, cold molding, and resin transfer molding. One of the oldest known molding processes is compression molding. Material is placed in a mold that's shaped like the desired product or part, then formed by heat and pressure. If you think about making a waffle, you've got a good idea of how compression molding works. Heat and pressure force the material into all areas of the mold. After the plastic hardens and cools, the part is removed from the mold. Compression molding is a batch process. The parts are made in batches instead of continuously, and that's its biggest drawback. Batch processing limits how much product can be produced in an hour. Sometimes an extruder is used to make preformed bits of material, or preforms, that are then loaded into the mold. It's not a good process for very complex parts with close tolerances and those with long molding cycles. Compression molding's advantage are that it's good for long production runs of moderately complex parts and for large bulky parts. The production starting costs and mold maintenance costs are low, and there's little raw material waste. Compression molding is used to make products such as dinnerware, buttons, electrical parts, large containers, and appliance housings. In the injection molding process, plastic granules from a hopper are forced through a heated cylinder or barrel, where they are melted and mixed. Then a screw or plunger injects the material into a mold held together by hydraulic pressure. After the material cools, the mold opens and the part is forced out. Injection molding is good for manufacturing in small complex parts with close tolerances and parts that require very little finishing. Fillers or inserts can be used in the mold along with the plastic, and the scrap can be reused if the part is made from thermoplastic. Most importantly, although it's a batch process, injection molding can be highly automated, increasing the number of products produced per hour. Because molds are expensive, injection molding isn't a good process to use for products with short production runs of small numbers. Additionally, the initial equipment costs are high. Some common items manufactured by injection molding are toys, refrigerator parts, instrument panels, battery lights, and model car kits. Extrusion works by pushing the plastic material through a heated barrel, which heats, melts, and mixes the plastic, then forces it through a die at the end of the barrel. By using different dies, different shapes are produced. The three main shapes are profiles, such as tube and rods, films and sheets, and coverings on wires and cables. Extrusion can also be used as a co-production process to melt, mix, and compound plastic raw materials, such as in compression molding and injection molding. In this profile extrusion machine, thermoplastic rods are being extruded, cooled in a water bath, blow-dried, and chopped up into pellets to be melted again in another manufacturing process. Extrusion is probably the most widely used plastics manufacturing process. It's common because it's relatively low in cost and the dies used are fairly simple, but it can only be used to produce continuous shapes. Products made with extrusion include plastic pipe, floor tile, siding for houses, and coating on electrical wire. Blow molding is another plastics molding process, although technically it could be also classified as an extrusion process because extrusion is sometimes used to produce the parison, or hollow plastic tube, that is then molded later in the process. In extrusion blow molding, that hollow tube of hot plastic or parison is produced in a continuous feed. The mold closes on the tube, sealing off the ends. Then, air is injected into the hot parison, which blows it against the mold walls, forcing it into shape. The product cools and the piece is removed. With extrusion blow molding, there is scrap at the bottom of the piece which is trimmed off at the end of the process and can be remelted in the extruder. Extrusion blow molding works well because most thermoplastics can be used as a material. The extruder is basic to many molding processes and may already be available. Although the cost of the die is lower than those for injection molding, disadvantages include the high cost of machinery, the waste produced by trimming, and the additional processing operations needed to complete the manufacturing. Blow molding is the process used to produce the plastic milk jugs, motor oil, and other household bottles. Another extrusion process is blown film extrusion. In blown film, a thin-walled tube of plastic similar to a parison is extruded through a round die while air is blown inside to stretch the tube to a larger diameter. As the tube is pulled upward, it's cooled by air blown from a cooling ring and is then flattened as rolls pull it together. The tube can be taken up in one continuous roll, like we see here, slit and opened to create a large single sheet, or perforated and sealed widthwise to make plastic trash bags. Stretching the film as it's cooling gives it more strength. With blown film extrusion, large widths of film up to 42 inches wide can be produced with very high strength. But the control of the film thickness during production isn't perfect, and good melt elasticity is needed in the plastic chosen as a raw material. Common blown film items are plastic grocery store bags, greenhouse covers, and weed mulch. Plastic thermoforming starts with a sheet of plastic material, usually extruded in a separate operation. The sheet is clamped into a frame, then held in a heating oven where it's heated to slightly above its melting point. The sheet is then placed between male and female halves of a mold, and vacuum and air pressure is used to form it to the mold shape. After cooling, the sheet is removed and additional trimming is done. Thermoforming is a relatively low-cost operation and works well at making smooth walled shapes with detailed features. Also, multi-layered sheets can be used as the raw molding material. A disadvantage occurs when using relatively deep female molds. The plastic thins at the upper edge and in the corners of the part. Straight vacuum forming is limited to simple, shallow designs. Also, pieces must usually be trimmed. Items such as cottage cheese containers, ice cube trays, and the clear retail packaging in stores are manufactured by thermoforming. Plastics often need to be assembled together after their initial manufacturing. This is usually considered a secondary operation in the manufacturing process. Assembling can be done by bonding the parts together through adhesion, cohesion, mechanical fastening, or friction fitting. Ultrasonic welding is a way to fasten plastic parts through cohesion or mingling the molecules between the two parts. Ultrasonic energy is used to vibrate the molecules in the plastics mechanically. The ultrasonic vibrations are produced by a machine and directed onto the parts through a tool called a horn. Different shaped horns give different shaped patterns of attachment. As the molecules vibrate, they heat and melt, then mix and cool together, making a spot weld. In this example, vibrations from the horn penetrate the first plastic strip into the lower strip, and the molten plastic flows between, bonding the parts. In addition to assembling parts after manufacture, plastics can also be decorated. There are a variety of decoration methods: coloring, painting, hot leaf stamping, plating, engraving, printing, in-mold decorating, heat transfer, and pressure-sensitive labels. Pressure-sensitive labels are one of the simplest ways of decorating a product, usually in the same production line where the product is produced. Labels are pressed on the product and adhesive causes them to stick. Many different products are labeled in this way, most commonly food packages and bottles. In a manufacturing environment, following good safety practices is critical. Although each location and machine is unique, the following general safety practices should be followed. Read and follow all safety signs. At the beginning of each shift, check that all safety covers, shrouds, interlocks, and emergency stops are in place and operating properly. Keep your work area neat, cleaning up any spills of liquid, resin pellets, or trimming scrap. Wear all required protective personal equipment, including eyewear, hearing protection, and clothing. When a machine jams, find the cause of the jam and have it repaired before restarting production.
The biggest thing I hear from my customers is that they need more highly skilled people and that they don't get enough of them. They can't find enough of them. They advertise for months and they don't get any responses. And it's really because there aren't enough plastics programs yet, there aren't enough students graduating, and it's something that's very, very much needed today.
Job opportunities in the plastic industry are excellent. While the total number of jobs in all manufacturing has gone down in the last 20 years, employment in plastics manufacturing has grown an average of 3% a year. That's $179 billion a year in sales and over 3.2 million jobs nationwide. Not only is it a growing industry, but the types of jobs within the industry are always expanding.
Basically, there's more jobs than there are people to fill them, so you have very good choice of where you go and what you end up doing.
Plastics is a growing field. If you look around, there's plastics in everything, where it be from your toys to your car or fans. It's just everywhere, and it doesn't look like it'll ever go away. And they need a lot of people, and they have more jobs than people can fill. And so it's an interesting field, and it's always changing, and if you like a challenge, then this is a field to go into.
Typically, a graduate from our program, Manufacturing Engineering Technology, has 3 to 4 job offers prior to graduation, and salaries will range anywhere from $35,000 to $45,000 annually.
Whether it's as a machine operator, assembler, or machinist, data processor, mold maker, or engineer, A graduating student can always find a good job in the plastics industry. And the key to finding a good job is education. An education that includes all the science, math, chemistry, and computers that you can take. An education that will help you understand and use advanced plastics technology.